So now if you look at this illustration, we have each string of 3 panels containing 350 watt panel. They are all connected in series. So each 3 will obtain VOC of 337.2, which means times 3 it will get 111 point what? 37.2 times 3. What do we have? Each one string of 3 panels will have 111.6 watt voltage. And look at our VOC range. We have 195 watt VDC. So since we got that, which means we can be able to add more panels in a string. We can make it 3-3, we can make it 4-4. The essence of using connecting panels in series to form a string is to what? To align with what? The VOC range. And our VOC range is 195. So which means we can connect more than 3 number panels in series to get wide range of what open circuit. Only when you are dealing with what? MPPT solar charge controller. Okay, now we use this 3 panel per string. So which means we are going to do parallel connection to connect all the panels to work together. Okay. So as such, this is our negative terminal. We take negative terminal into the battery. And then we merge all the positive together as well. Like this. Okay, for us to connect it to the charge controller terminal. So by doing this, each string here, we are obtaining 111.6 V DC. But how about the current? We are maintaining the current of a particular solar panel because in series connection, current is constant, voltage is added. Okay, so now since the voltage is added, each panel is generating 37.2 V as what? VOC. Each panel is 37.2. So now by connecting 3, we obtain 111.6 VDC. So the current will be maintained, which is what? 8.81 amps. The same thing here. 111.6 VDC, 8.81 amps. Can you see it? So now till the 12th one. So for us to get the actual current these panels are generating, you say I total equals to 8.81 times what? 12. What do we have? 8.81, which is the IMP of a particular solar panel. Literally, we are going to get what? 105.72 amps. Can you see it? Approximately 106 amps. Meanwhile, we are dealing with which type of charge controller? 120, which means it can accommodate this current conveniently. We still have a space. Can you see it? So this is it. So if you can remember, when we deal with PWM charge controller, we have to get 2 charge controllers. We cascade them together to give us 160 amps for it to power only 24 panels. All right? But here, we use 36 number of panels using only 1 charge controller, and all is well. So what is remaining now? What is remaining? Inverter. Okay? Okay. Inverter. It has plus terminal and minus terminals. Plus and minus. Okay? So now, you can take in anywhere. You can take it here, you can take it anywhere you want. Do you understand? Okay? You can decide to say, okay, if that is the case, let me allow this cable to pass through the very first terminals here. Okay? And then, For the inverter, you connect plus, plus, minus, minus. Do you understand? It's still the same thing. Do you get it? So this is the DC input. Okay? And this is the AC output. It also has, okay, like here, and then you have AC input. Do you understand? You have a slot for the AC in and AC out. AC in, it means you allow your inverter to what? To accept national grid to charge, to pass through your inverter. You can, you see, we have, like I explained in our previous classes, we have a bidirectional inverter that has a rectifier, inbuilt rectifier in it, which means it can charge the battery via national grid, through the national grid, right? It can also serve as the inverter itself, all right? So now, that is why you have two AC, AC output and AC input. This represents NEPA, that is national grid, KEDCO, okay? National grid, okay? And this represents inverter output. Okay, so this is it. And normally, this is how it will be. Is there any question? Any question? Question? Okay, I'm with you.
I'm asking about the AC,
AC output? Okay.
Are you going to use it to generate a light to a house or how the house?
Indeed. What is inverter? Inverter is a device that converts a DC current into AC current. And that AC current is the one that we use in our homes, in the offices, and what have you. So that AC output is the one that inverter is giving out to serve as what? At the power source. Do you understand? AC in is the NEPA national grid, the very energy you are getting from NEPA. That is AC in. It will pass through the inverter and then to your load. Do you understand? Question?
I can see. So we have two types of settings. It's either you connect your NEPA directly to your inverter, or you set up your changeover.
It's not a setting. It's not a setting. Look at it here. This is our polarities from the what? Inverter to the battery, plus and minus, right? Can you see, what did you see here? AC input. You connect this to the socket outlet. Do you understand? And this is AC output. This is what the inverter will give to the home appliances. While this one, you are connecting it to the what? To the plug of national grid to pass through the inverter, so that in case if you want to charge your batteries through the inverter, you can have dual source of charging, solar panel and the inverter itself.
I want to ask a question.
Yes.
Can you use DB to connect
Exactly.
AC input?
Exactly.
So that's one I know.
That is how you do it. If you want to power your inverter, you want to get your AC input, you don't just tap it from the socket outlet. Why? Because possibly your socket outlet is getting power directly from the inverter input output. Do you understand? If you do that, what do you think will happen? There will be a feedback. A voltage from inverter is also charging the inverter itself, which is dangerous. So which means you have to tap it from the DB, distribution board, directly. Do you understand? It receives power from national grid, from the pole, through the cutout, then you pass it here with control. Exactly. Do you understand? While this one is going to be minus of the battery and this is plus of the battery. Do you all get it? So we have two powers, two ACs. AC input and AC output. That is what I did there.
This is the
This is inverter. Do you understand? Okay? So I hope you enjoy this very session. we will continue to be doing more sessions on inverter, particularly on connections, troubleshooting, maintenance, and troubleshooting. Okay, thank you very much. See you next week for the next application on solar system. Thank you very much.